Before we start, please like and subscribe to my channel for more fascinating content like this. Have you ever wondered how an airplane, a massive structure of metal, takes to the skies? It's a question that has puzzled and fascinated humanity since the dawn of time. The idea of flight, of soaring above the clouds, has been a constant source of awe and wonderment. In this modern era, aviation has become a cornerstone of our global society. It connects people, cultures, and economies like never before, yet the mystery behind how these colossal machines defy gravity remains a source of intrigue for many. The marvel of aviation is an intricate dance of science, technology, and human ingenuity. It's a symphony of aerodynamics, mechanics, and innovation. And today we're embarking on an adventure to unravel this mystery, to make the complex simple, to illuminate the dark corners of the unknown. Our mission to demystify the process of flight, to explain in layman's terms the science and technology behind how an airplane flies. Ready to take off on this fascinating journey? Buckle up! To understand flight, you need to know about the 4 forces that work on an airplane in motion. First up is lift. Lift is the upward force that opposes the weight of the plane and holds it in the air. This force is produced by the forward motion of the airplane and the shape of its wings. The wings of an airplane are designed in a special shape, flat at the bottom and curved at the top, a shape that helps air move faster over the top than the bottom. This difference in speed creates an upward push. That's lift. Next we have weight, or as some of us like to call it, gravity. It's the force that pulls the airplane down due to the mass of the airplane and the acceleration due to gravity. The weight is always directed towards the center of the Earth, and it's this force that lift needs to overcome for the airplane to ascend. Then there's thrust. Thrust is the forward force that propels the airplane through the air. It's produced by the airplane's engines, whether they're jet engines, propellers, or even rockets. The engines suck in air at the front, compress it, mix it with fuel, and ignite it. The resulting hot gas blasts out of the back, pushing the airplane forward. Finally, we come to drag. Drag is the resistance that an airplane faces when moving through the air. It's like trying to walk through water. The water resists your movement. That's drag. There are 2 types of drag: parasitic drag, which includes form drag and skin friction, and induced drag, which is related to the production of lift. These 4 forces, lift, weight, thrust, and drag, are in a constant tug of war. For an airplane to maintain stable flight, these forces must be in balance. Lift must equal weight to prevent the airplane from suddenly shooting upwards or plummeting downwards. Similarly, thrust must equal drag to keep the airplane moving at a steady speed. These forces must balance for an airplane to fly. Now, how does an airplane achieve this balance? The key to flight lies in one force, lift. Now, lift can seem like a magical concept, a bit like pulling a rabbit out of a hat. But just like any good magic trick, it's all about understanding the principles behind it. So, let's dive into the science of lift, shall we? Lift is essentially a force that acts upwards against gravity, helping an airplane to rise into the sky. The key to creating lift, air pressure differences. The Bernoulli principle, named after the Swiss mathematician Daniel Bernoulli, explains this perfectly. Bernoulli discovered that as the speed of a fluid increases, its pressure decreases. Air is a fluid, and when it moves quickly over the curved top surface of an airplane wing, it creates a lower pressure area. Meanwhile, the air moving under the wing, where the surface is flat, is slower, creating a higher pressure area. This difference in pressure is what creates lift. The higher pressure beneath the wing pushes up against the lower pressure above it, causing the wing and hence the airplane to rise. Now let's talk about the role of airplane wings, also known as airfoils, in creating lift. Airplane wings are designed in a specific shape, flat on the bottom and curved on the top, to take advantage of the Bernoulli principle. As the aircraft moves forward, air splits at the leading edge of the wing, with some air traveling over the top and some underneath. The curvature of the top surface causes the air above to travel a longer distance, which means it moves faster, decreasing the pressure above the wing. Meanwhile, the air moving beneath the wing is slower, creating a higher pressure. So the airfoil shape of the wing, combined with the aircraft's forward motion, creates the pressure difference needed for lift. It's as simple and as complex as that. The wings of an airplane do a fantastic job of creating lift. But how does an airplane move forward? An airplane moves forward thanks to the force of thrust. Now, let's dive into the heart of the matter, the remarkable engines that generate this thrust. These marvels of engineering and design are the workhorses of the aviation world, tirelessly propelling massive metal birds across the skies. But how exactly do they do it? In essence, airplane engines work on the principle of Newton's third law of motion. For every action, there is an equal and opposite reaction. In the case of an airplane, the engine, whether it's a propeller or a jet engine, pushes air backwards. As a reaction to this, the airplane is propelled forwards. It's a fascinating dance of physics that plays out thousands of feet above our heads every day. Let's consider propellers first. As the blades of a propeller cut through the air, they push it backwards. This action creates a forward reaction, propelling the aircraft forward in much the same way as a swimmer pushes water backwards to move forward. Jet engines, on the other hand, operate a bit differently. They suck in large amounts of air at the front of the engine using powerful fans. A part of this air is then compressed, mixed with fuel and ignited. The resulting explosion forces the mixture out of the back of the engine at high speed. This backward push propels the airplane forward. Still, it's not just about generating thrust. These engines also have to constantly battle against the force of drag, the air resistance that tries to slow the airplane down. It's a delicate balance, but one that these engines manage to maintain with an astonishing level of efficiency. So, in a nutshell, the force of thrust is all about pushing air in one direction to make the airplane move in the other. It's about overcoming the force of drag, and it's about the sheer power and precision of airplane engines, whether they're spinning propellers or firing jet blasts. Thrust propels an airplane forward. But how does it steer and change direction? That's a question we'll tackle in our next scene. Stay tuned. Steering an airplane involves manipulating the forces of flight. So how does a pilot change the direction and altitude of an airplane in the vast sky? Well, they do it by utilizing the airplane's control surfaces, the ailerons, rudder, and elevators. Let's start with the ailerons. These are small hinge sections on the outboard portion of a plane's wings. When a pilot operates the control stick left or right, the ailerons are deflected up or down. This changes the shape of the wing and alters the amount of lift it produces, causing the airplane to roll and turn to the left or right. Moving on to the rudder. The rudder is a movable surface located on the vertical stabilizer at the back of the airplane. By using the foot pedals in the cockpit, the pilot can move the rudder left or right. This yaw motion changes the direction of the airplane's nose left or right, allowing the pilot to line up the aircraft with the direction of flight. Lastly, we have the elevators. These are movable surfaces on the horizontal stabilizer, also at the tail of the airplane. When the pilot pulls the control stick back or pushes it forward, the elevators move up or down. This changes the pitch of the airplane, causing it to climb or descend. These control surfaces, along with the engine's thrust and the shape of the airplane's wings, allow the pilot to precisely control the aircraft's direction and altitude. It's a complex dance, a balancing act of physics and skill, of manipulating the four forces of flight: lift, weight, thrust, and drag. In the hands of a skilled pilot, these forces become an art form. They allow the pilot to perform the intricate ballet of takeoff, flight and landing, to navigate through the vast theater of the sky, and to bring passengers safely to their destinations. The combination of lift, weight, thrust, and drag, along with the pilot's skill, enables the magic of flight. In the world of aviation, the symphony of flight doesn't stop at control. There's more to it. After mastering the art of control, pilots need to understand the importance of communication and navigation. Communication is vital for pilots to relay information about their aircraft's position, speed, and intentions to air traffic control and other aircraft. This allows for the safe and efficient management of air traffic. Navigation, on the other hand, is the process of planning, recording, and controlling the movement of an aircraft from one place to another. Pilots use various methods and tools for navigation, including visual references, navigation aids, and modern GPS technology. In essence, the symphony of flight is a harmonious blend of control, communication, and navigation. It's about understanding and manipulating the forces of flight, communicating effectively with others in the sky, and navigating through the vast open theater of the sky. It takes skill, knowledge, and a great deal of practice to become a proficient pilot, but the reward is the freedom to soar through the sky, to explore the world from a unique perspective, and to experience the magic of flight on a daily basis. Next time you board a plane, take a moment to appreciate the symphony of skyward soaring that makes your journey possible. Thank you for joining us on this journey through the science and art of flight. In the next video, we will delve deeper into the world of aviation. Until then, safe travels!